So looking at number one, what category does this fall under? Power rule, good. All right, there's only a single term in the problem. Even if there were parentheses up top, if it was like x squared, parentheses, x plus 1 squared, we still don't want to get thrown off by that, right? That if there's only one term in the denominator, typically that's a good fit for power rule. So even the problem looked like this, right? Even if there were parentheses, this is also power rule. That 5 root x is no issue. That squared can be expanded out. So don't let, we don't want to think that, oh, every time there's a parentheses is going to be a U substitution. We want to be able to recognize these scenarios when power rule is a better fit than U substitution. So begin splitting up into individual fractions. Oh, sorry. All right, so number one is basically like a review problem from your previous quiz. All right, split up into individual fractions, get all the x's to be in the right places, and then do power rule. Okay, what about number 2? What does that look like to you? The substitution. Because why can we not do power rule? The square root, right? I can't distribute something through a square root. I'm breaking order operation rules here, so that's why we can't do it. Now, if it was 2x parentheses 1 minus 3x squared, then we can, right? If it was a problem like this, right, this is power rule, because we can resolve this, right? Expand that out, FOIL that out, distribute the 2x, but we can't do that here. So I want to make sure that we continue to know why something is used substitution versus why it's not power rule. Okay. Whenever you go through U substitution, you know you're on the right track if all the x's go away. If the x's don't go away, we can't ignore that and just start doing our calculus process. We either went down the wrong step or we have to find a way to get the x's to go away. So if the x's don't go away, we have to make sure we take care of that before we consider anything with our calculus rules. So 2 over -6 is the same thing as -1/3. Apply power rule. 1/2 becomes 3/2 over 3/2. And don't forget, if you're doing U substitution, that U variable needs to be brought back in terms of x at the end. Number 3 and 4, I just want to talk about the first steps because I want to make sure I get to all the different problems. But look at number 3 here. What's the process for number 3? What's our strategy there? Power rule. Notice that this is not, there's no difficulty in expanding this, right? Now, if it was square root of x plus 2 or x minus 2, like a previous problem, right? If they're adding and subtracting inside the square root, we know that we have to remove power rule as an option, but this is doable, right? 5 root x, that's 5x to the 1/2. You can distribute that through the 4 minus 3x squared. If you can expand this and just rely on power rule. All right, so again, anything with parentheses, we don't want to just assume that it's always power rule, that is use substitution, right? These are the two big cases that we want to look for in terms of something that is meant to be power rule. If you can see it being expanded, then we should do that first. Okay, number 4, what's our strategy there? Right, too messy for any one rule to handle, right? So we do have to go through use substitution. What could be our u value? Okay, we see a set of parentheses, right? Our u value is that 3x squared. The derivative is 6x. That 6x will pair up nicely with 5x. The x's cancel out. We know secant squared u has a rule. We have a rule for secant squared u, which is tangent. So everything should work out pretty nicely once we get that in terms of u. Okay, so this one, u sub, it should work out pretty cleanly, 3 and 4. Okay, I'll have you guys finish this on your own for homework. Let's look at number 5 here. Can we do expansion power rule here? In too many terms inside that radical, we know we're stuck with our next option, which is use substitution. Let's go ahead and get our parentheses to show up. Okay, what's our u value? 7 minus x. But we see some issues ahead, right? We know that the x squared is not going to cancel out. We're still going down the right path. It's just that we have some additional work ahead of us. We know we have to go through that additional change of variable to eventually get that x to go away. Okay? Dividing by -1 is the same thing as multiplying by -1. All right, we have to understand that there's an issue here. We can't jump into power rule and say x cubed over 3, u to the 3/2 over 3, plus c, and end the problem, right? There is a lot, still some work ahead of us. And the issue is that the x squared needs to be converted. Otherwise, we can't go through anything with power rule. So our connection is having to play around with this equation. How can I rearrange this equation to make a suitable replacement? X equals what? Mm-hmm. So this is going to go in for that. Okay. When we make that substitution, it doesn't quite mean that we're ready to do power rule, but at least we've gotten everything down to one variable, right? If you're going through use substitution, everything has to eventually convert to be in terms of u. I can't have use substitution and have some parts being u and other parts being x. Now, at this stage, at least everything's in terms of u, but we still have a lot of algebra to resolve, right? We can't do power rule unless all the parentheses are gone and everything is nicely expanded. So what I like to do is I like to push that negative u to the 1/2 in front. And then step by step, do the algebraic steps, which means I'm going to FOIL out the 7 minus u. I'm going to write that out twice, FOIL it out, then distribute the negative u to the 1/2. And then everything is nicely separated. And then I can do power rule. So this is probably one of the longest problems to have to go through because of all the cleanup and all the steps involved. Okay, now we're ready for power rule. Let me double check I'm doing this. Some students in the past have left this as their answer because they've done all this work and they feel like they've already reached the end. And so they would, at this stage, they will convert this in terms of X and just add plus C. But we haven't done power rule yet. All this is to get to the point where we can do power rule. So make sure that you still do the calculus after you reach this step. And then another common mistake that students have is they will clean this up, but then they will forget to bring the u in terms of X. If this is the mistake that you're making at the end, that's a relatively minor mistake. Okay, I mean, if you can get to this point and you forget to do that last step, I'm pretty happy with your progress because you've done all the important steps. It's just that a lot of students do forget to bring the X back, so just be aware. That's a common thing. Okay, questions with 5? All right, let me come back to 6 if there's time. I want to make sure I can hit all the other problems on the back page before I run out of time. So we'll come back to 6 if we have time. Page 14. So we're asked to find the derivative of a function that has a definite integral in it. So essentially, we're trying to do this. We're trying to find the derivative of this mess. And so this falls under the category of second theorem because we are doing opposite operations on the same function. So here are the two variations of second theorem. So we do this version if one of the bounds is a constant. But if both are variables, then we have to go through that formula that I have up there on the board. We have to do the f of p of x times p prime, but then minus, and then we got to plug this in and do the same thing, f of q of x times q prime. So again, this is a shortcut method. We're not having to go through a full power rule, use substitution, then plug in the upper and lower bound, then clean it up, then find the derivative. We can get our answer all in just one line because this is a predictable procedure. We're doing a process and we're coming right back. So that's why we can predictably just go to the very end. I do want to get this root x to be set up because I know I have to involve power rule eventually with that p prime. So f of p of x, all we're doing is we're copying the exact same expression. We're just making a substitution there. Derivative, x to the 1/2 minus, and then do the same thing, plug the function into the bounds into the expression. Times q prime. Let's just do a little bit of cleanup here. Oh, did I copy it wrong? 2x cubed. Sorry, 2x cubed. Copy the problem wrong. Sorry, I copied that lower bound to be 2x squared instead of 2x cubed. So if we plug that in, we'll get 1 minus parentheses 2x cubed squared times the derivative of 2x cubed, which is 6x squared. This is better. Right. Any questions? All right, number 8, you can try on your own later. Let's look at number 9. The strategy for number 9 is we're going to physically draw the graph out. And the definite integral is essentially area related. So if we have a nice geometric graph in front of us, we can just add up the two add up the shaded region, and then get our area. But the reason that we can do this here and not for other problems is because absolute value functions is going to create a V shape, and the V shape is we can create triangles out of it. We have nice geometric shapes that we can identify. But graphs that are more complicated with curves don't fall into a nice geometric area formula. So that's why we don't do it for that, but we do it for this, because we could go through power rule and piecewise function, but it's just a lot easier to just draw two triangles and add up the areas. So first thing is, let's figure out what the graph looks like. So we're looking at y equals absolute value of x plus 2. We're trying to figure out what that graph looks like, and we're extending the graph, the region from -5 to 6. Okay, where's the vertex for this absolute value function? Where's the v? Where's that sharp point of the v going to be? -2, 0. Yeah, whatever causes your expression to be equal to 0, that's the location when your graph is going to, where that graph is going to be at its center. So from -2, you're going to extend your graph in both directions in the shape of a V. And you're going to go all the way to -5 to the left and all the way to 6 on the right. You don't have to be super accurate. As long as you have the basic shape, you can use the function to help you find the dimensions. So we see two right triangles form. So now the next step is, can we find the locations of these order pairs? Because if we find locations of that order pair, we'll have enough information to build the height and then eventually the width of our triangle. So we're going to plug -5 into the absolute value function. Because we know that this function that we just drew is defined by this y equals absolute value of x plus 2. So if I plug -5 into the function, what's the y value going to be? What's -5 plus 2? That's just what? Yeah, -3. And then absolute value of -3 is +3. So therefore, the order pair is -5, 3. We're going to focus on that y value there. That y value is also the height of that. It's also going to represent the height of my triangle. So I know that the height of my triangle is 3 units off of the ground. And then this is also 3, right? If I just count the units, that's 3 units there. So I have my base and height for my triangle, for my first triangle. Second triangle, I'm going to plug 6 into the function to get that y value. If I plug 6 in for x, what's 6 plus 2? 8. Absolute value of 8 is 8. So 8 also happens to be 8 units off of the x-axis, which represents the height of my second triangle. And if I count from -2 to 6, that's a distance of 8 as well. Area of a right triangle is 1/2 base times height. So we're just going to do that twice. 1/2 base times height for the first triangle. 1/2 base times height for the second triangle. Okay, you guys can try number 10 on your own for homework. Let's look at number 11. Any questions so far? All right, I want to show you what a particle motion looks like. Particle PV saw this on the quiz where I gave you the second derivative and you found the antiderivative to get to f prime, find the antiderivative to get to f of x. But now, instead of calling it f prime, and f double prime, we're calling it position, velocity, acceleration. So you're going to start at acceleration, find the antiderivative, get to velocity. From velocity, take the antiderivative, get to position. And then along the way, you're plugging in the order pairs and solving for c. So let's see if we can set up our steps for number 11. All right, so we're going to start off. This is number 11. All right, so you're given acceleration function. Find the specific function for velocity. We know that if we want to get from acceleration to velocity, we simply have to take the antiderivative. So I'm going to set up what I want to do. I know that once I get that acceleration through the integral process, the result is going to give me my velocity function. Okay, so try that. Everything is nicely set up. Power rule. No messy, complicated rules to go through there. So try that. See if you can build your antiderivative, which will get you from acceleration to velocity. Twelve x, sorry, 12t squared becomes 12t cubed over 3. 18t becomes 18 t squared over 2. 4 becomes 4t, and don't forget plus c. We'll do some cleanup here, but do we have something that can help us solve for c here? We have an order pair that we can use at this stage. Yes. Yeah, -1 in for t and 9 in for velocity because we have an order pair at this level. Okay. Order pair, 9 in for velocity, -1 in for t. We clean all that up. All those cancels out. My c value ends up being 0. So my velocity function has no constant. Because, I mean, I could do a plus 0, but I could also just leave it out as well. So this is my halfway point. So now we got to do this process again because we're trying to get up to position. So if I want to get to position, my position function is just the integral process of my velocity. So I'm just setting up what I want to do. The integral of that expression will result in my position. Right, go through power rule again. Another plus C will show up. And do we have an order pair at the position level to help us solve for C? Okay. So take the order pair that's given to you. 1 in for T, 3 in for X, or into your position, your X. Once you solve for C, go back to your general solution and replace the C with 1. Okay. Any questions with? So virtually the same thing as your quiz, just different notations. Instead of F and F prime, you're using velocity and acceleration. But what if I were to ask you for velocity and position general solution? So your general solution for part A would look like this, right? Let's say I didn't give you any order pairs, then you would leave it in this form. But then what would your position look like? So 4t cubed will still become 4t over 4, 9t cubed over 3, 4t squared over 2, but then this will turn into what? C t, but then it'll produce its own what? K or C sub 2. Yeah. So these would be the general equations if the order pairs weren't provided for you. All right, one last thing to go over with you is number 12. Number 12 says, given the region that you see between -2 and 5, find the average value. So average value, we have a formula for that. Place all your A's and B's with what? -2 and 5. Now, this is not an average value theorem, problem that we can do using power rule, and then plug in the upper lower bound like previous one. This one, you're actually going to be adding the regions in terms of the area. But let's do this first. This is an important step. Make sure that you're looking at just the region between the graph and the x-axis. You may see other shapes, but those shapes are not part of the diagram. So this is an important skill here. See if you can go ahead and shade in because you're only concerned about these regions. And sometimes your interval may not include everything you see on the graph. So make sure that you're only paying attention to what is specified in the interval. We're going from -2 to 5. And these are all different shapes here. We have squares, which is base times height, triangles, which is 1/2 base times height. Semicircle, but let me ask you this, what's the area of a circle? Pi r squared. So semicircle is just 1/2 pi r squared. So then for the triangle, we'll do 1/2 base times height. For the square, we'll do 1/2, we'll do base times height, 1/2 base times height, 1/2 pi r squared, 1/2 base times height, and base times height. But the only adjustment is, what do we need to do that's special about this region here? We need to make this what? Negative. Yeah, these are all negative y values. These are displacement. It is still area, but this will produce a negative y value. So let's be positive, 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 negative, positive, positive. Now, after we get all that number, whatever it is, you don't have to clean it up without a calculator. You can just leave your answer unsimplified. That's only going to represent you the integral portion. You still have to make sure you multiply by 1/7 in order to get the average height that we're looking for. So this first triangle here, 1/2 base times height, so that's 1/2. Square base times height is 1. Triangle, 1/2 base times height is 1/2. My radius for the semicircle is 1, so 1/2 pi radius squared, 1 squared, plus 1/2 plus 1. 1/2 plus 1/2 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3.5 is 3.5, minus pi over 2. But that only represents my integral portion. Don't forget about that 1/7. It's area divided by the width will give you the height. You can leave your answer unsimplified. As long as I see all the numbers there, that's what I'm looking for. We pretty much went through everything on that list. I didn't go over even and odd functions. We can do that some tomorrow. We do need to start our calculator portion, but we can review even and odd functions. I didn't do trig, so we can do that tomorrow for practice as well. And then also definite integrals. We didn't do that. That's number 6 on the previous page. So your homework is just to finish up page 13 and 14, the ones that we didn't get to. Right. Page 13 to 14. Health session tomorrow, 7:50 to 7:40, and then Friday morning, health session 7:15. Your test is Friday. All right, come get your phones.
Do I still owe you work from the first project?
Gotta check your page factor 8 of your homework. You have I think that's really the main thing that I want to. Let me check that. Not all of that. I'll bring it to you. So no, that's really cool.
So,
You can take your time with this. I mean, but, huh? Yes. So, yeah. Okay, great.
page 1.